All right, today I'm just going over our Quiz 3 proof practice. So our first problem is really just an algebraic proof. So I have given you an equation and I'm trying to build a proof that shows yx equals 2. So a good starting point is usually to use the given. And in the proofs that we've been doing, that is pretty standard. We start with the given. So over here, I'm going to start with 4x plus 5 times x minus 2 equals 6 plus x. This is given to me. Now the paths that we take through this proof, we can vary, and that's okay. What I'm looking for is, can you back up your argument? Can you justify the steps that you're taking to get to your desired conclusion? So for me, my next step would be to distribute that 5 right here. So I would write this as 4x plus 5x minus 10 equals 6 plus x. So how did I get there? I used the distributive property, or distribution property would be fine. Okay, next I would probably consolidate those linear terms on the left. I would combine my like terms. So now 9x minus 10 equals 6 plus x. So how did I get there? Well, I would write that I combined like terms. All right, so next move. Well, I got some options. I would probably subtract the x from both sides. So now I would have 8x minus 10 equals 6. So I got there using the subtraction property of equality. Okay, next move, I'd probably add the 10 to the other side. So 8x equals 16. I'm using the addition property of equality. Okay, last thing I would do is divide each side by 8, and that would get me that x equals 2. I use the division property of equality to get there. Okay, so I've reached my conclusion. I've justified my steps along the way. I do have leftover spaces. I usually shade them in. So I was able to reach my conclusion in 6 steps. And I really just want to keep stressing that there are multiple pathways through our proofs. You do not have to match mine perfectly. What you have to be able to do is be able to explain yourself and explain how you are connecting the dots along the way. All right, next one, we are proving the vertical angles theorem. And then once we've proven the vertical angles theorem, we can start to use it in the new batch of proofs. So here's our starting point. We know that 2 and 3 are vertical angles. So angle 2 and angle 3 are vertical angles given. Right? We know that because they're in the opposite position. And we're trying to prove, why is it that the angles themselves must be congruent? So we're building off of prior knowledge. We're using our understanding of other postulates. Postulates are those very basic, obvious statements that we accept as true. They're so easy to see. We build off of properties. We build off of definitions. And once we've proven a theorem, we can start to use it in its own, in new proofs, right? So in new batches of proofs that we see. So once we prove vertical angles as a theorem, we will see it show up in the new style of proofs that we're going to actually do later on in this lesson. All right, so now I'm trying to connect 2 to 3. So if I think about another angle relationship that I know right here that 1 and 2 form a linear pair. And linear pairs are always supplementary. I also know that 1 and 3 form a linear pair also, right? Linear pairs are supplementary. So if I'm trying to build to this congruent statement here, I would probably start by building equations. So I'm going to say, well, the measure of 2 plus the measure of 1 equals 180. And the measure of 1 plus the measure of 3 also equals 180. Now I could have put those in separate steps, that would have been fine, but since I'm going to use the same reason, I just put them together. So we know that both of those pairs of angle measures sum to 180 because they're linear pairs, and linear pairs are supplementary. So I use as my reason, I use the linear pair property. But I am okay if you call that a postulate. So linear pair postulate would be fine. Definition of linear pairs would be fine. If you want to write a statement and say, well, if angles form a linear pair, then they're supplementary, right? Their measures add to 180. I will take that too. So again, just remember that this is really all about, can you explain yourself? Can you justify the connections that you're making from step to step? All right, so now when I look at where I am and where I need to get to, what I can see is that these two measures sum to 180, so do these. And if they both sum to 180, these have to be equal to each other. So here I'm going to use the transitive property. Let me remind you what that is. So if I know that A is equal to B, so I'm saying that this is A, this is B, and this is C, also equal to B, then I can finish off that three-way connection and say that A must be equal to C. So if I'm building a little chain of 3 or more connections, then I'm arguing the transitive property. I could also visualize this as substitution, because if A is the same as B, C is the same as B, it's like taking the C and plopping it in for the B right up here. So both of those reasons would actually work. So I'm going to write my statement, measure of 2 plus measure of 1 equals measure of 1 plus measure of 3. And like I said, that could be transitive, property of equality, or I could argue substitution. So substitution, property of equality. Okay, so now that I'm here, I'm trying to get 2 to 3. And I can see, well, I got 2 and 1 on the left, 1 and 3 on the right. So I can just go ahead and subtract away that measure of 1. So now I have the measure of 2 equals the measure of 3. So I got there using subtraction. So subtraction, property of equality. And I'm so close right now. I know that my measures are equal, but I want my angles to be congruent. So I'm just converting to a more appropriate structure. So I'm saying angle 2 is congruent to angle 3. I would cite the angle congruence postulate. So remember that we use that postulate when we are converting from congruence to equality or vice versa. Okay, so I reached my conclusion. I reached it in 5 steps, so I'm just going to shade in step 6. If I had taken these two statements and made them separate, I would have used all 6 boxes. Okay, and then one more thing here. If you had written that as a statement, of course, that's fine too. So you could have said something like, if measures are equal, then the angles themselves must be congruent. That is fine. All right, next up. So here I'm giving you that 1 is a supplement of 2. 1 is congruent to 3. Can we prove that 2 is a supplement of 3? Okay. So here, this is actually a case where I would split up my 2 givens. Sometimes I lump them together, and sometimes I split them up. right? There's no right answer here. It's how we are building our argument. So I'm going to start with that first given because it gives me something to build off of. So angle 1 is a supplement of 2. All right, so angle 1 is a supplement of 2 that is given to me. All right, what does that actually mean, right? If 1 is a supplement of 2, it means that they are supplementary. Their measures must add to 180. So in step 2, I'm going to go ahead and build myself an equation. I'm going to say that the measure of 1 plus the measure of 2 equals 180, right? That's what it means to be supplementary. So I'm going to say that that is the definition of supplementary or supplement. Either one would be fine. All right, so 1 is a supplement of 2. What does that mean? It means that together their measures have to add to 180. So I'm using definition of supplementary or definition of supplement. That would be fine. All right, so why is that helpful? So right now I know 1 and 2, their measures sum to 180. Really, in the end, I want 2 and 3. I want to show that their measures add to 180. So I'm going to go ahead and I'm going to throw in that other given. So angle 1 is congruent to angle 3, given. So I can see that, well, if the angles are congruent, couldn't I, in just a couple steps, couldn't I swap the 3 in for the 1 right here? And then wouldn't I have 3 and 2 being supplementary? I can see that. So you want to be trying to think a few steps ahead. What can I use? What's going to help me reach my end game? So right now I have my figures are congruent. Ultimately, I want my measures to be equivalent so I can plug one in for the other. So I'm going to do a quick conversion. Measure of 1 equals measure of 3. So I'm back to the angle congruence postulate. So when my angles are congruent, their measures are equal and vice versa. You usually see me draw this symbol and then this detail, right? That's really the angle congruence postulate. If my figures are identical, their measures must be equal and vice versa. So now that I'm here, I know that my measure of 1 and 3, they match, they're equivalent. So I can take that measure of 3 and plug it in for this measure of 1 right here. So I can say that the measure of 3 plus the measure of 2 equals 180. And I got there using substitution because I'm plugging in values that are equivalent. So substitution property of equality. So now that I'm here, right, I've shown that these measures add to 180. So if I have 2 angles whose measures add to 180, well, they have to be supplementary. So I can now reach my conclusion that angle 2 is a supplement of angle 3. And my reason, I would say definition of supplementary. Again, but if you wrote that as a sentence, that's fine too. So you could say, well, if 2 angles have measures that add to 180, then the angles must be supplementary. That's fine. I just think it takes longer. So I have no problem with you guys writing the formal reason instead of the sentence, but I'll take it as a sentence as well. That is always okay. All right, so I got there in 6 steps. Let me block out my extra spaces and then move on to the second page. All right, so take a moment and flip your paper or just pull out that second page. All right, so here we're going to prove the alternate interior angles theorem. It's very similar to the alternate exterior angles theorem. We start off with these parallel lines, and line C is a transversal, and we're trying to prove why is it that alternate interior angles, why is it that angle 1 and 3 must be congruent? So again, we're building off of prior knowledge, prior relationships. We're building off of postulates or theorems that we've already proven, properties and definitions. So let's start with the given. I would put them together. So I know that A and B are parallel lines, and then line C is a transversal. Given to me. Okay, in the end, I'm trying to sync up 1 and 3. So I try to focus on one of those two angles. Let's say I focus on angle 1. If these are parallel pathways, so let me draw in the arrow. So if these are parallel pathways and C is my transversal, well then I know that angle 1 is congruent to angle 2. They are corresponding angles. That's our postulate, because we can see that if we slide angle 1 into 2's position, it would overlap perfectly. So corresponding angles is our postulate. All right, so I've connected 1 and 2. I'm trying to get 1 and 3. So right now, if I look at angle 2, well, I can link up angle 2 to 3. They're vertical angles. I've just proven it. I can now use vertical angles theorem in my new batch of proofs. So I can say that angle 3 is congruent to angle 2. Vertical angles theorem. All right, so now I've connected 1 to 2 and 3 to 2. So now I can connect 1 back to 3. It's a little three-way connection, right? It's a little chain rule, the transitive property, or I could visualize it as substitution, right? If 1 is identical to 2, 3 is identical to 2, then I can take that 3 and plop it in for 2. So I would take it either way. So I would take this as transitive property of congruence, or you could argue substitution. Property of congruence. Okay, so I got there in 4 steps, short and sweet. Let me block out my extra space. And slide it up. All right, the next one we're writing a proof for the same side exterior angles theorem. We could also call it consecutive exterior angles. That's fine. And we have the same starting point. So we have that these pathways are parallel. Line C is a transversal. And we're trying to build to the relationship of angle 1 and 3 being supplementary, that their angles add, their angle measures add to 180. So I would start with my given, right? Pretty standard place to start. So A is parallel to B, and that line C is a transversal. Given. All right, so in the end, I want to get 1 and 3. I want their measures to add to 180. So I have our conclusion as an equation. So when I look at my picture and I think, well, is there an equation I could build that uses one of those angles and their measures would add to 180? I can see it right here. I could go through 2 and 3. So I can build an equation that says the measure of 2 plus measure of 3 equals 180. So again, I'm building off of prior knowledge. I know those measures add to 180. They form a linear pair. So I'm citing the linear pair property. All right, so look at where I am now and look at where I need to be. So the only difference in these two equations is that here I see the measure of 2 and here I see the measure of 1. So I want to establish a link between 1 and 2. and I see, oh, well, they are congruent angles. Because my lines are parallel, I can see that 1 would slide into 2's position perfectly. They are corresponding angles. So I'm citing the corresponding angles postulate. All right, and when my angles are congruent, well, their measures have to be equal. So I'm going to take a moment and convert it to an equation. So measure of 1 is equal to the measure of 2. That is my angle congruence postulate. All right, so I'm so close now. I'm so close. So here I had measure of 2 plus measure of 3 equals 180. I wanted to read measure of 1 in place of that measure of 2. And I'm ready to swap it out. So since measure of 1 equals measure of 2, I can take that measure of 1 and plug it in right here, and I can get to my conclusion. So measure of 1 plus measure of 3 equals 180. And I got there by plugging in an equivalent measure. So I'm getting there using substitution, property of equality. And I got there in 5 steps, so I'm going to block out that last space right here. All right, the last one here, problem 6, was really just meant to be a little bit of a challenge for those who want it. So I put a little star next to it. So it's proving another relationship that we just haven't proven yet. So I'm showing that why is it that 1 and 3 must have measures that add to 180, right? Those are not corresponding angles. They're not alternate interior or exterior or same side interior or exterior. So it's just another pair in the diagram that have to have measures that add to 180. So can we prove that relationship? So of course we're going to start with the given again. We know that A is parallel to B. Let me mark it with my arrows. And that line C is a transversal. Given. All right, so again, I'm looking at where I need to be. I want to show why is it that 1 and 3 have to be supplementary? Why did their measures have to add to 180? So I might look at my picture and see if I can build an equation that looks really close to that one, and I can see it right here. I can say that the measure of 3 plus the measure of 2 equals 180. All right, why? Well, because they form a linear pair. So this would be the linear pair property. All right, so looking at where I am right now and where I need to be, right? I want it to be measure of 1 plus measure of 3 equals 180. And right here, I have a 2 where I want it to be a 1. So I need to establish a link between 1 and 2. Well, 1 is congruent to 2. They are corresponding angles. If my lines are parallel, 1 can slide into 2's position perfectly. So I'm using the corresponding angles postulate. Okay, and then I want to be able to swap out where I see a 2 here with a 1, right? I want it to look like this in the end. So I need to first change it from the figures, the angles themselves, to their measures. So measure of 1 equals the measure of 2, angle congruence postulate. Okay, so then I'm super close, right? I know measure of 1 equals measure of 2, so I'm just taking that measure of 1 and I'm going to insert it in for that measure of 2, and I'm at my conclusion. So measure of 1 plus measure of 3 equals 180. And I got there using a little substitution, property of equality. So what you should be noticing here is that this little 6 proof, right, this little optional one at the end with the star, it ended up being a very similar pathway as problem 5, right? We got there almost the same path, right? We synced up the linear pairs, used corresponding angles, converted to the right format, and then used a little substitution to seal the deal. And we got to our conclusion. All right, that's all I have for today. Have a good rest of your day.